Alright guys, so I'm going to go through and solve all these equations. We've already looked at the methods to solve. Here's a reminder in case you don't have the notes. We're going to try to isolate our variable. So, on this first one, we're going to use our log property to bring that 2 inside. So I'm going to have log of x squared equals log of 9. Now I want to get rid of the log, so to do that I'm going to raise it as an exponent of the base. Now the base for these logs are 10, so that's going to be 10 log of x squared equals 10 raised to the log of 9. Now what happens is these 10 log 10s go away and I'm just left with x squared equals 9. Now I take the square root, so x equals positive 3 and x equals negative 3. But we have to check for extraneous solutions. So that means if we plug negative 3 back in, that means we're taking the log of a negative, which we know that can't happen. And so x equals negative 3 is not a solution. Our only solution is x equals positive 3. All right, on the next one, there are a couple different ways to solve this. One way you can do this is just to go ahead and divide out the 3 so that you have log base 3 of 4x minus 7 equals 2. Now I have one term on each side, so I'm going to raise this as an exponent of my base, which was 3. Now I have 3 squared on this side. Now 3 log 3's are going to cancel out, and so I'm left with 4x minus 7 equals 9. I'm going to add 7, so 4x equals 16, divide by 4, and x equals 4. Now you have to check and make sure this works. 4 times 4 is 16, minus 7 is 9. We can take the log of 9, so we know that's our correct answer. Okay, here we don't have a single log term, so we need to combine these first. So I'm going to have log base 4 of x plus 3 times 2 minus x equals 1. Now I'm going to raise these both as a power of 4. Now 4 log 4 will cancel, and I'll just be left with x plus 3 times 2 minus x. 4 to the first power is 4. Now I'm going to FOIL. So that gets me negative x squared. Well, I'll do it in order. That gets me 2x minus x squared plus 6 minus 3x equals 4. Combine like terms here, so you have 6 minus x plus x minus x squared equals 4. I'm going to move everything to that side so I can get it equal to 0. So I'll have x squared plus x. When I subtract the 6, I'm going to have minus 2. Now I'm going to factor this x squared plus x minus 2. So 0 equals x. 1's plus, 1 is minus. So I have factors of a negative 2 that are going to add to a positive 1. So that means I have to have a positive 2 and a negative 1. To solve for x, you set each factor equal to 0. So x minus 1 equals 0, x plus 2 equals 0. For this one, x will equal 1. For this one, x will equal negative 2. Now we have to check and make sure these solutions work. If I were to plug 1 in here, that would be 1 plus 3 is 4. So we're taking the log of a positive, so that's fine. 2 minus 1 is still 1, so that's okay. So 1 is an answer. Now let's check for negative 2. Negative 2 plus 3 is a positive 1, so that's okay. 2 minus a negative 2 is a positive 4. So we get a positive in both, so that's also an answer. So just because our answer for x is negative does not mean that it's not an answer. You have to plug it back in and test whether you're taking the log of a positive once you plug it in there. Okay, for 4, I have to combine these first, so I have log base 3 of x times x minus 6 equals 3. So log base 3 of x squared minus 6x equals 3. Raise these as a power of 3 to get rid of the log. So those go away. I'm left with x squared minus 6x equals 3 cubed, which is 27. Now I'm going to move that 27 over, so I have x squared minus 6x equals 27. So x squared minus 6, I rewrote the exact same thing, didn't I? Let's try that again. Equals 0. So now I can factor this trinomial to be x plus something, x minus something. I need factors of a negative 27 that add to negative 6. So that's going to be a negative 9, positive 3. When I set each factor to 0, I get x equals negative 3 and x equals positive 9. If I plug 9 in there, I get 9, and 9 minus 6 is 3, so that's good. If I plug negative 3 in here, I'm going to get a negative number. So that can't work. So negative 3 is an extraneous solution. It's extra. We don't need it. Okay, here I have to bring this 2 inside and deal with this other log. So I'm going to have log base 3 of x minus 4 squared. Now, log base 3 of 9 can actually be evaluated. That says 3 to what power equals 9? So that's 2. So this whole term right here is just 2. Okay, let me get rid of that. Now I can add the 2 to the other side, so I have log base 3 of x minus 4 squared equals 6. Now I can raise each side as a power of 3. So I have x minus 4 squared equals 3 to the 6th. Now notice when I have x minus 4 squared, to get rid of a squared, I can always just square root. But what does square root really mean? If I have the square root of 3 to the 6th, that's exactly the same as raising it to the 1/2. And when I raise a power to a power, I multiply, so 6 times 1/2 is really just 3. So when I take the square root, not only do I have a positive square root, but I also have a negative square root. So x minus 4 is 3 cubed, but it's a positive 3 cubed and a negative 3 cubed. So we have a positive 27, and x minus 4 equals a negative 27. So now I'm going to add 4 to both sides here. So x is 31. So, add 4 again here. So x is negative 23. Now check and make sure we have a solution. Negative 23 minus 4 gives me a negative 27. We can't take the log of the negative, so that's not a solution. If we plug 31 in there, we do have a solution. Okay, next, log base 1/2 of 4x to the 3/2 equals negative 3. We have one term on each side, so I can go ahead and try to get rid of the log. Now my base is 1/2, so it's 1/2 to log 1/2 of 4x to the 3/2 equals 1/2 to the negative 3rd power. Now what happens on this side is I now have 4x to the 3/2. Now 1/2 to the negative 3rd, the negative means I flip it, so this means I have 2 cubed, so that's just 8. Now to get rid of this 3/2, I'm going to have to take a power on both sides of 2/3. It works the same way as if I am, as if I'm taking the square root when I have a squared. A square root is really just 1/2. So I'm taking the reciprocal power. Reciprocal of 3/2 is 2/3. So I'm going to do that to both sides here. Those are going to cancel, so I'm left with just 4x. Now what is 8 to the 2/3? Well, the cube root of 8 is 2. 2 squared is 4. Divide by 4, x is equal to 1. If I plug 1 in here, I'm taking the log of a positive number, so 1 is my answer. Okay, now this problem is that method 1, where we can change the base to the same number and then drop out the bases. And I'll show you why we can drop out the bases. So we have 3 to the x plus 1. Now we can change change 81 to base 3. 81 is really 3 to the 4th. Now, just as taking the exponential of a log gets rid of a log, taking the log of an exponential will get rid of this base. So I can take a log base 3 of 3 to the x plus 1 and take a log base 3 of 3 to the 4th. Well, remember, our properties tell me that a log of my base that I'm taking that of will cancel out. So I'm just going to have left x plus 1 equals 4, because that 4 is all that's left after that log base 3 of 3 goes away. So that's exactly like getting rid of my bases here when they're the same, so that I have x plus 1 equals 4. Now subtract 1, so x is 3, and I'm good. When you have the exponential problems, you do not have to check and make sure that you have a positive or anything in there. It's only when you start with the log. Okay, now I have 2 to the x equals 5. Now this one's a little different because I can't change 5 to base 2. So I'm going to have to take the log of both sides. I'm just going to take, well, log of 2 to the x equals log of 5. Well, my multiplication, or my power property, says I can move that x out front, and now I'm going to divide by log 2. So x equals log 5 over log 2. Let me grab my calculator, my handy dandy calculator. So that is 2.32. Now you could have done this one another way. You could have just changed this to logarithmic form. Log with base 2 of 5 is x. Then use change of base. So x equals log 5 over log 2. Sorry, that's an L. Which is exactly what we put into the calculator to find that 2.32. Okay, here. I have this 8 out front. I've got to get rid of it first. So 3 to the x equals 5/8. So now I can change this to logarithmic form. So log base 3 of 5/8 equals x. Now I do change of base. Log of 5/8 divided by log of 3 equals x. Now that's what I put in my calculator. And I get negative 0.43. Okay, here I have to divide by that 500 first, so I have 10 to the 0.3x equals 6 over 5. Now this looks like something we can change into log form. So log base 10 of 6/5 equals 0.3x. Now I can get my x by itself by just dividing by 0.3. So x equals, now log of base 10 is the one in my calculator, so I can just put log of 6/5 divided by 0.3 in my calculator, and I get 0.26. Okay, here, this one is very long and complicated, but it's not hard, it just takes a long time. So right here, we know we can't get 5 and 3 in the same base. So we have to take the log of both sides. And we can't change this to exponential because it won't help us. It's not something to a power equals just a number. We've got two things with an exponential there. So I'm going to go ahead and take the log of both sides. Now what's going to happen is my exponents are now going to come down. So I'm going to have x minus 2 times log 5 equals 3x plus 2 times log 3. Now I want to get x by itself, so what I need to do is I need to distribute these logs. I need to have x log 5 minus 2 log 5 equals 3x log 3, not base 3, sorry, plus 2 log 3. Now I want to get my x terms on one side and everything without an x on the other side. So I'm going to have x log 5 minus 3x log 3. Now I'm going to move this 2 log 5 over here. So 2 log 3 plus 2 log 5. Now notice here both of these have an x. So they have a common factor of x. So I'm going to pull that out. So now I have log of 5 minus 3 log 3. And we still have this thing. Now what I'm going to do, I'm just going to clone this real quick so I don't have to rewrite it. Change its color. Now I need to get x by itself. I'm going to condense this first to make it a little simpler. To condense, we're dividing because we have subtraction, so I'm going to have log of 5 divided by, the 3 goes inside, so 3 cubed is 27. I'm also going to condense this here. This 2 will go inside, so that will become 3 squared, which is 9. So 9, and this 2 will go inside here, so it becomes 5 squared, which is 25. So then we've got 9 times 25, which is 225. Now I've got x times a log here equals another log, so I'm just going to divide by that log. So x equals log of 225 divided by log of 5 over 27. So I've got negative 3.21. Okay, and number 12, I need to combine this first. So I'm going to have log base a of x equals, now this 2 goes inside and becomes an exponent. So that's log of 9 plus log of 5 multiplied 9 and 5 together. So that's log a of 45. Now remember how to get rid of the logs. I have to raise those as a power of a. Well, the a log a's are going to cancel, so x is just 45. Okay, here. Again, this log base 3 of 9 will cancel to, well, it won't really cancel. It's evaluated to be 2. And then I have log base 3 of x plus 2. I can subtract the 2. So I have log base 3 of x plus 2 equals 1. Raise these both as a power of 3, so then I have x plus 2. 3 to the first power is 3. Subtract 2. So x equals 1. I plug that back in, 1 plus 2 is 3, so it is my answer. Okay, here, this one is another complicated one. Now, we're going to have to take the log of both sides, and that exponent is going to come out front. So it's going to be 1 plus x times log of 0.3. This 2 minus x is going to come out front. Then I have log of 1.7. Distribute the log throughout, so I have log of 0.3 plus x log 0.3 equals 2 log 1.7 minus x log 1.7. Now I want my x terms all on one side and my everything else on the other. So I'm going to have x log 0.3 plus x log 1.7 equals 2 log 1.7 minus log 1.3, or excuse me, just 0.3. Factor out my x, and I can go ahead and condense those logs. We're adding those logs, so 3 times 1.7 is 0.51. And I'm going to go ahead and condense these logs. This is going to be 1.7 squared. So I'm subtracting, so that means I'm going to have log of 1.7 squared divided by 0.3. And it's a very long decimal, so I'm just going to leave that as 1.7 squared over 0.3. Now I just need to divide by log 0.51. So I have log of 1.7 squared over 0.3 over log of 0.51. So that equals negative 3.36. Okay, here I have the absolute value inside my log, but that doesn't make a difference. I'm still going to raise this as a power of my base. So I'm going to have my absolute value of x plus 4 left. 3 squared is going to be 9. Now my absolute value is going to mean that I have two answers. So x plus 4 is going to equal a positive 9, and x plus 4 is going to be a negative 9. So I'm going to subtract 4, so x equals 5. Subtract 4, so x equals negative 13. Now both of these are answers because even if I plug in a negative 13, I am taking the absolute value, which will make that 9 positive. So both of these are my answer. Here, what you need to recognize with this is in the form of, we have this squared plus a b times that a plus some c equals 0. It's exactly like a quadratic that needs to be factored. And I'll simplify this a little bit so you can see that. This is 10 to the x squared minus 5 times 10 to the x plus 4. So pretend that that 10 to the x is like an x. How would you factor x squared minus 5x plus 4? We would factor that to be x minus 4, x minus 1. But we don't have x, we have 10 to the x. So instead of x minus 4 and x minus 1, I'm going to have 10 to the x minus 4 and 10 to the x minus 1. Now I have both of these factors that I need to solve. 10 to the x minus 1 equals 0. 10 to the x equals 4. 10 to the x equals 1. Now this one can be solved by doing change of base. Log of 4 divided by log of 10. For log base 10 of 10 is really just 1. So log of 4 is 0.60. Now if you put log of 10 in the calculator, you're still going to get 0.60. Now here we have x is 0, because 10 to the 0th power will be 1. So we have 0 and 0.60. This one is very similar, except you notice here that I have a common factor of e to the x. So I'm going to factor that out. E to the x squared minus 3 equals 0. I have two factors, e to the x equals 0 and x squared minus 3 equals 0. So I have x squared equals negative 3. Take the square root, so x equals plus or minus the square root of 3. Remember, we both have that positive and negative. Now let's look at this e to the x equals 0. Can I raise anything to a power that will get me 0? No, even if I raise this to a negative, I'll still get a reciprocal. If I raise this to the 0, that'll still be 1. So this does not exist. So this does not produce an answer, but plus or minus the square root of 3 would. Okay, those are my last examples. Remember, you can go back and pause and look at these again. If you need additional help, you need to come see me for tutorials.